So the switch, we found it really easier to review than C. C you can make quite obscure quite quickly. The Spark Ada has a quite short learning curve to produce good quality code. And by that, I mean code that is as fast, as memory space efficient as C. The execution time and space is identical for equivalent code between Spark Ada and Maestro C using the Ada Core GNAT GCC compiler toolset. There was a learning period. There are some things which you have to be used very carefully and be aware of. But once you've gone through that, then you can write Spark Ada that's just as efficient as C. The productivity of Spark Ada may be slightly better than from Maestro C in terms of actual coding. It's certainly not worse. So these things are so strong. I think, why didn't we do this before? It's because Spark and Ada had an association with more expensive projects. And the Maestro C is the way the automotive companies do things. So as we'd done a lot of automotive-related work in the past, that's the route we came down. But those factors above means that Spark Ada is a very good tool, full stop, regardless of the application, if you're comparing it with Maestro C. We didn't have any ARM backend at the time. There was no GNAT ARM backend. So we ported the GCC ARM backend onto the Spark system, well, the Ada compiler, and that was quite straightforward. When you change tools at all, there's a huge amount of verification to do again. So that was the only negative side of that, the amount of re-verification. The project's so successful that we intend to replace all the Maestro C with Spark Ada in the next phase. The current phase is that we've done the design, done all the production tooling, got the functional safety certification. But in Europe, there's one other certification we need, relating to the PPE directive, the Personal Protective Equipment Directive. And because the whole industry is really opposed to functional safety, we're finding that stage much harder to get through than if we hadn't gone down that same functional safety route. A bit of an irony. But it look like we should be getting that certification later on this month. It's taken a lot more time than we expected. So basically it's a complete engineering design. The production tooling, we've got 78 injection plastic moldings. We have 14 die-cast metal moldings. We have a total of 173 production tools for this project. So it's not simply a one-off, it's designed for high-volume production. It's been extensively tested, obviously, to get through the PPE directive, it has to be. And those pictures I showed earlier with the unit in use. The full process that we use has been certified by CIRA to 6158 SIL 3. The limit was the Maestro C, and also we could only find one type of oxygen sensor. We are working on a sol gel second type of sensor because we need diversity of sensors. And so that would allow us to go to SIL 4 rigor. But the Spark Prover is what we'll be using heavily in the next stage to try to reduce the cost of the code verification. So rather than just the earlier benefits, it looks like Spark Ada is an alternative, good alternative to Maestro C. This benefit that we plan to use heavily for the next phase should allow us to get substantial cost reductions. We retain the exhaustive test coverage requirements as the validation levels can't be replaced by the proving system. There's one interesting experience we had on this. In the specification, we had a FIR filter, finite impulse response filter. The software engineers had not done courses on Laplace transforms and things like this. So when they read the equations, they looked like a regular normal equation. So they entered it and put it in, and they thought the word fur, because they'd heard it, meant fur, like a fur coat, like noise. Of because the filter's job was reduce noise. So they implemented this, and it went through all the verification and passed. It then went to the validation team, and the first it failed in like 5 minutes. They started up and it just failed instantly. And then we looked at why does this happen? Because things should not fail instantly when they get to the validation team. And it was simply that there was this divide in understanding. So the importance of having this completely separate group that have gone down an entirely separate path with the formal modeling tools and their test suite as a way of checking what the understanding is that's come out of the software engineering group, we'll certainly retain. But to do that, we have to have really extensive test coverage. So that's a quick summary of what we've done with this project. We're enthused with Spark now. The next project, the marine industry gives lots of opportunities for companies involved in high-integrity software. Ships have lots of things which are really need to be safe. Dynamic positioning systems, for example, various navigation and pitch control mechanisms. But the marine industry doesn't have much of this in place. Now, I'll give one example. It's in the dive area, but comments extend to the whole of the marine industry. The simple dive computer, you can buy them in any dive shop for a few £100. My hand is that computer, and it says I can go to the surface in 0 time. This one is my colleague who was stuck to me like glue because I'm testing rebreathers. And he says we need 20 minutes. What's happened? Same thing here. Same well-meaning amateurs who design rebreather controllers also do dive computers. That one here is a deadly fault. 20 minutes of decompression, your blood would just turn like champagne. And having big air bubbles in your joints is not a pleasant way to go. Now, I was trying to sell this at the time because we have a pile of these dive computers we didn't need. And someone said, oh, do you mind if I buy that off you? It's my own personal one. And I said, yeah, fine. Unfortunately, he had one of these already, and he's in Sweden. And he worked for a Norwegian company, but he became a paraplegic on a rebreather due to this exact fault on this model of dive computer. And if it hadn't been for the really excellent medical response in Sweden, he'd be dead. So these are safety critical systems sold to the public in large volumes, and there is no knowledge of functional safety or reference in any of the specifications. So here, the software doesn't come anywhere close to meeting 61548. And people confuse ISO 12207 with a functional safety standard. So one of our next projects is actually go and do some dive computers because there's definitely an opportunity there. And that project will be wholly in Spark Ada. So after the break, we have a couple of these systems, and I'll put them on the table. So when you come back from lunch, you can actually see what these things look like. The commercial one is the big yellow heavy thing, and the sports one is the light, small one. And these things talk to you, unfortunately. Giving you a lecture, the last thing you want is some unit saying, auction low, bail out now, in a voice. So I'll switch that off when lunch finishes. So you're going to see that running. Again, thanks for your attention.